When I started working as a data analyst, I still remember that in my first months, I was really struggling to follow what we were discussing in the meetings with my team, simply because there were a lot of terms that I was not familiar with, but my team apparently was using on a daily basis. Ciao guys, welcome back to my channel. If you haven't met before, I'm Lore. I'm working as a data analytics lead in London. In this video, we'll cover all the terms and concepts that you must know as a data analyst in case you don't want to be like me, completely lost during meetings. And we're going to cover all of them in the quickest way possible, but still giving you a good idea of their meanings. This is generally a video that I wish I watched when I started, and I'm sure that you will be familiar with some of these concepts, but I promise that you will definitely learn something new. But if you knew all of them, I want you to comment genius down below. And also let me know in the comments down below if I missed any terms that you think are important to know so that we can all help each other. And well, without further ado, let's get started. So the very first concept is data lake. Data lake is a storage repository that can store vast amounts of raw data in its native format. It handles structured, semi-structured and unstructured data, and it offers massive scalability and is usually based on distributed and often open source technology. And while Amazon S3 is probably the most popular storage platform to build and store data lakes. Then we have data warehouse. Data warehouse is a centralized repository designed for query and analysis. It integrates data from multiple sources and is optimized for data analytics and reporting. A retail company can use a data warehouse to combine sales data, inventory levels, and customer information to optimize stock levels and improve customer satisfaction. Then we have data mart. So data mart is a subset of data warehouse. It focuses on a specific business function or department, for example, sales and finance. And so it's designed for a specific community of knowledge workers. A sales data mart could provide the sales team with easy to access data on customers' purchases, helping them to analyze trends. Then we have data wrangling. So data wrangling is the process of cleaning, transforming, and organizing raw data in a structured and usable format. It involves tasks like removing duplicates, handling missing values, and converting data types. For example, transforming raw sales data into a standardized format with consistent units allow businesses to compare performance and make informed decisions. Then we have data integration. So data integration is the process of combining data from different sources or different formats and systems into a unified and consistent view. It could involve merging customer data from online sales and in-store transactions so that you can help retailers gain a holistic view. Then we have data modeling. So data modeling is the process of creating a structured representation of real-world data. It's like designing a blueprint that defines how data should be organized. For example, in an e-commerce company, data modeling helps define how customers' orders, products, and reviews are related and stored in a database, making it easier to retrieve and analyze information effectively. Then we have data mining. So data mining is the process of discovering patterns, correlations, anomalies, and statistically significant information from large data sets. Companies can use data mining to analyze customer purchase history and identify products' preferences. Then we have data visualization. So data visualization is the art of presenting complex data in visual forms, like charts and graphs, to basically make it easily understandable. It helps professionals grasp trends, patterns, and relationships in data. And so, for example, a sales chart can visually display revenue trends over time, helping the business to identify growth opportunities or areas that need improvement. And the two most popular data visualization tools are Tableau, which is owned by Salesforce, and PowerBI, which is owned by Microsoft. Then we have data schema. So database schema is an abstract design that represents the storage of your data in a database. And so it describes both the organization of data and the relationships between tables in a given database. And so developers plan a database schema in advance so that they know what components are necessary and how they will connect to each other. Then we have structured, unstructured, and semi-structured data that we already mentioned before. So structured data is organized in rows and columns, often in a database. And so an example is a relational database like SQL with clear tables and schemas. Unstructured data is the data that doesn't have a specific format or organization. So for example, emails, videos, and social media posts. And then semi-structured data has some organizational properties, but not as strict as structured data. And so example is JSON or XML files with tags. Then we have descriptive statistics, which involves summarizing and presenting data to gain insights. So in industry, it's used to understand trends, patterns, and key characteristics of a dataset using, for example, methods like the mean, the median, and the mode. And so retail companies might use descriptive statistics to analyze sales data, revealing the average number of sales or the highest selling products. Then we have inferential statistics, which involves drawing conclusions and making predictions about a population based on a sample of data. It helps us make informed decisions by analyzing a subset of data to infer insights about the entire population. And so a car manufacturer might use inferential statistics to estimate the average fuel efficiency of all vehicles produced based on a sample of cars that are tested. Then we have skewness, which is a measure of the asymmetry of the distribution of a variable around its mean. So if the curve is shifted to the left or to the right, it says to be skewed. And so positive skewness indicates a distribution that is skewed towards the left, while negative skewness indicates a distribution that is skewed to the right. Then we have correlation. So correlation measures the strength and direction of a linear relationship between two variables. So in industry, it helps uncover connections between different factors. For example, a positive correlation between advertising spending and sales indicates that higher spending often leads to increased sales, and obviously these influence the marketing strategies. Then we have causation. So causation refers to the cause and effect relationship between two variables, where a change in one variable directly influences a change in another. For example, an e-commerce company can find that offering free shipping all the time increases sales. And so correlations means that two variables change together, while causation implies that changes in one variable directly influence the other. Then we have regression analysis. And so regression analysis is a statistical method to model the relationship between a dependent variable and one or more independent variables, often used for prediction and understanding variable relationships. And so if we use the previous example, if a company observes that increased advertising, which is the independent variable, usually leads to higher sales, which is the dependent variable, then they can use regression to quantify the relationship and predict future sales from planned advertising expenses. Then we have outlier. So outlier refers to a data point that deviates from the overall pattern of a data set. And so outliers can impact analysis and decisions. In finance, an unusually high stock price on a certain day might be an outlier, for example. Then we have normalization. So normalization is a data pre-processing technique that scales features to a common range, for example, between 0 and 1. In a customer database, normalizing income and age helps a bank evaluate loan applications fairly, preventing one feature from dominating the decision-making process due to its large scale. Then we have data governance. And so data governance involves creating and enforcing rules, processes, and policies for managing data across the organization. It ensures data quality, security, and compliance. It basically helps companies to maintain accurate and reliable data. For example, a healthcare organization uses data governance to ensure that patient records are securely stored and accessible only to authorized personnel. Then we have ETL, which stands for extract, transform, and load. This is a process used in the industry to gather data from various sources, which is the extract, then clean, structure, and enrich it, which is transform, before finally loading into a storage or database for analysis, which is the load part. And so companies can use ETL to gather sales data from different stores, standardize the format, and load it into a centralized database. Then we have ELT, which is extract, load, and transform, which is a newer method for achieving the integration of data from across an organization. And so here data is extracted from its origin, loaded into the data store, and then transformed. And so the transform action will typically happen on a as-needed basis versus the ETL, while all data is transformed before it's loaded. Then we have time series analysis. So time series analysis involves studying data points that are collected at evenly spaced intervals over time, and it's used to forecast future trends. So a utility company might analyze historical energy consumption patterns to predict peak demand, ensuring that they allocate the resources in an appropriate way. Then we have A/B testing. So A/B testing is a method where two versions, A and B, of something are compared to determine which performs better. So it's used to optimize user experience and marketing strategies. A website can run a A/B test by showing one group of users the original design, which is A, and another group of users a new design, which is B. And then they analyze which version leads to a higher click-through rate, for example. Then we have hypothesis testing. So this is a statistical method used to determine if there is enough evidence to support or reject a claim about a population based on a sample. So a food delivery app might use hypothesis testing to determine if a new discount strategy significantly boosts order numbers, or maybe if that's not the case. Then we have predictive modeling. So predictive modeling involves using historical data to create a model that predicts future outcomes. For instance, an insurance company uses predictive modeling to assess risk factors and estimate future claims. Then we have SQL or SQL, which stands for Structured Query Language, which is a language used for managing and querying relational databases. So it's crucial for data retrieval and manipulation. For instance, a hotel chain can use SQL to track room occupancy, and me as a data analytics lead, I use it pretty much on a daily basis. Then we have Python libraries. So Python libraries are collections of modules or functions that provide specific functionality or features. They help avoid the reinventing the wheel by providing pre-written code for common tasks. These obviously make it easier and more efficient to perform specific tasks. And so in data analytics, the most common are NumPy for numerical operations. Then we have Pandas for data manipulation and analysis. Then we have Matplotlib for data visualization and plotting. Then we have scikit-learn for machine learning tasks, and also TensorFlow for deep learning. Then we have month-over-month and year-over-year. So MOM, so month-over-month and year-over-year, are comparisons of data between consecutive months or the same month in different years, respectively. So for example, if a company had sales of $100 in January and $110 in February, the month-over-month sales growth would be 10%. And if a company had sales of 100 in February 2022 and 120 in February 2023, the year-over-year sales growth for February would be 20%. Then we have YTD, or year to date, which refers to the period of time from the beginning of the current calendar year up to the present date. So YTD is used for tracking financial performance and trends. And so, for example, imagine that today it's August 1st, 2023. The year to date refers to the time from January 1st to August 1st, 2023. Then we have KPI, which is a key performance indicator, which is a measurable value that reflects how effectively a business is achieving its objectives. And so, for example, an e-commerce company might track KPI like conversion rate and average order value to understand the website performance. Then we have clustering. So clustering is a machine learning technique that groups similar data points together based on their characteristics, and it's used for segmentation and pattern recognition. For example, a marketing team can apply clustering to group customers with similar purchase behaviors, allowing basically tailoring marketing strategies to boost their customer engagement. Then we have classification. So classification is another machine learning task where the goal is to predict the category or class of an object based on its features. And it's used for various applications like fraud detection. And so, for example, a bank can employ classification to automatically identify fraudulent transactions by analyzing transaction patterns and obviously safeguarding customers' financial security. Then we have feature engineering. So feature engineering is the process of selecting, transforming, and creating new features from raw data to improve machine learning model performance. So in email spam classification, features like email length, number of exclamation marks, and presence of certain keywords can be engineered to help the model distinguish between a spam and legitimate emails. Then we have ensemble learning, which is a technique that combines multiple machine learning models to improve predictive performance and reduce overfitting. And so in medicine, combining predictions from multiple algorithms like random forest, gradient boosting, and neural networks can provide a more reliable diagnosis by reducing individual model biases and errors. Then we have NLP, which stands for natural language processing, and it's a field of AI focused on enabling computers to understand, interpret, and generate human language. And so in the industry, NLP is used for tasks like sentiment analysis or chatbots, and also language translation. So for example, NLP helps customer service chatbot understand user queries and respond intelligently. And so this is a complete list of concepts that I thought every data enthusiast must know. I know you might be familiar with some of these concepts from the list, and also some concepts may be completely new to you. Do let me know in the comment section which concepts were new to you. And if you think this video was helpful, don't forget to give it a thumbs up and share it with friends who are interested in data science and data analytics. And also don't forget to subscribe to my channel, because this really helps me to reach even more people. I will leave here in the screen some data project tutorials that I've done using tools like Python and SQL. And well, enjoy the rest of your day. Ciao for now, and see you in the next one.